Hey everyone, today we're going to continue our lessons on data structures. Today we're going to be learning about dictionaries. This is the second data structure we're going to be covering in this lecture. It will not be the last, but it is the last in this current sequence of data structures. We'll be covering a couple more data structures as the semester goes on. Okay, so before we start talking about what a dictionary is in Python, we got to talk about what a dictionary is in real life, right? So you guys know what a dictionary is, right? A dictionary is just like a book that contains a listing of words along with their associated definition, right? So here on the left we have just a random page from a dictionary, right? It's a list of words, and then next to it it has, that word's definition. It's pretty simple, but we need to get a pretty in-depth understanding about how a dictionary works, like mechanically, before we can actually start talking about what a dictionary in Python is. Okay, so let's take a quick step back and look at a dictionary in more abstract terms. So like I previously said, a dictionary is just a big list of words that has, the associated definition of each word, connected to that word. If I'm using a definition to find what a word means, I use that specific word to go through the dictionary, and then once I've traversed the dictionary and found the word I'm looking for, I can access its definition. So if I want to know what cat means, the word cat, I open up the dictionary, I look for the word cat, and once I found the word cat, I get the definition of that word. I get what that word means. Now, a word, when you're traversing a dictionary, can only give you that word's definition. If I'm looking for cat, by looking for cat, I cannot get the definition of car or of plane or anything like that. I can only get the definition of cat. These these are like the basic mechanism of a dictionary. These three, descriptions. So with these in mind, we can, further, break down what a dictionary is. But these are three very important things that you have to keep in mind going forward into our exploration of what a real dictionary is, and they will massively help once we start talking about what a dictionary in Python is. Okay, so here we have a tiny dictionary. There's just three words in this dictionary, and if we really think about it, they're not really words, are they? They're entries, and an entry in a dictionary has a word along with its definition. Now, most dictionaries, they also have a bunch of other stuff like synonyms and other stuff like that, whether it's a noun or a verb, but we don't really care about that, all right? That would massively overcomplicate this. For now, let's just pretend that a dictionary is just the word you're looking for and the definition of that word. So this tiny dictionary has three entries. It has car, cat, and catapult. And if I were to open up this dictionary and look for the word cat, I would, go to cat, and then I would see that a cat is a small domesticated carnivore. If I want to look for car, I open up the dictionary, look for car, and then I would find out that a car is an, automobile. That really doesn't explain anything, but that's just what dictionary.com gave me. If I were to open up, our tiny dictionary again and look for the word catapult, I would get that a catapult, it's an ancient military engine used to hurl objects inferior to a trebuchet. Um, Now, this is a pretty limited dictionary because if I were to look for baseball, it's not in here. If for some reason the definition of a catapult changes, I can't really change it, but it's good enough for now. This is a general structure of a dictionary. So, taking a closer look at a specific entry in the dictionary, an entry can be split up into two parts: the word and the definition. So, the word is what we use to, traverse the dictionary. Like, if I have a word and I want to see what that word means, I can go on to the dictionary and, read through it and get to the part I want to get to and find, my word and its associated definition. You can't do that the other way around. If I have a definition, I can't open up a dictionary and look for my definition and then find what that definition, is paired with. I can only go from word to definition, not from definition to word. This is very important, and it will be very helpful when we get to what an actual Python dictionary is. Now let's say that we are now a brand new editor of the tiny dictionary company, and we now can add entries to a dictionary. So if we wanted to add an entry to a dictionary, we need two things, right? We need a word and the definition of that word, right? We can't just add a random word without a definition. We can't just add a definition. We need both in order to add an entry to the dictionary, right? So with these two things, we can, expand our current tiny dictionary. So let's say you want to add this entry to our dictionary. The word is microcontroller, and the definition is a small general purpose computer used in electronics and embedded systems. So this is good because we have our pair, we have our word with its associated definition, so that's all we need. So since we have everything, we could just add it to our dictionary. So after adding the word microcontroller to our dictionary, now we have a slightly less tiny dictionary, and we have all these 4 entries. Now, using the words, we can still traverse. I can still find car, cat, catapult, but now I can also find microcontroller. If I were to look up the word document, I still couldn't find it. And if I need to edit any of these, I could theoretically, since we're the brand new editors, that slightly less tiny dictionary company, we can. But this is pretty much all we need to understand, of how a dictionary works mechanically in order to jump into what a dictionary in Python is. Okay, so now let's talk about dictionaries in Python. So dictionaries in Python are just a type of a data structure, just like a list is a data structure. They will be very reminiscent of a list as you work with dictionaries. They'll be very vaguely familiar to a list, but something you must keep in mind, they are not lists. Even though they behave somewhat similarly, they are very distinctly not lists, and they have different qualities. So they follow the same general structure that the dictionary does, but the words we use are slightly different. We'll get into that in the next slide. And they can be used to implement really cool programs and to really save in code size. You can create really cool stuff using very little code using dictionaries. Right, so going back a couple slides, we saw this, and these are the parts of a normal dictionary. Specifically, it's the parts of an entry in a normal dictionary. We have our word, and then we have our definition. Now, if we switch over to the Python version of this, you might notice a small difference. All right, so can you spot it? So nothing really changed except the words. So instead of microcontroller being the word and then a small general purpose computer used in electronics and embedded system being the definition, microcontroller is now the key and the definition is now known as the value. So now in a Python dictionary, you don't use a word to look up a definition, you use a key to look up a value. But in terms of the overall mechanism, a Python dictionary and a real life dictionary work the same way. You use a key / word to look up a value / definition. So I've used a lot of abstract terms and just talked in really general aspects so far. But what exactly is a Python dictionary? Well, a dictionary in Python has the qualities listed on screen right now. It's a collection of data values, just like a list is. It is unordered, which is different from a list. This means that dictionaries do not have a built-in order to them. Lists do. Dictionaries are also indexed. You have to use an index system to access the values. Lists have that as well. In lists, you use like index 0 to access whatever is at index 0. In a dictionary, instead of using index 0, you use the key. The key would be the index to find out what is located at that, what is associated with that key. And it is changeable. We can modify the values in a dictionary in Python. Now, remember these qualities. You may be asked in the future, what are the qualities of a dictionary? Hint, hint. All right, so now we learned a lot about what a dictionary is in Python. Now let's learn how to actually work with these in Python. So on screen, I have the general structure of what creating a dictionary in Python looks like. So you have to use those braces, those curly boys that are on screen, and it must be in this format. You know, you must, let me get the laser pointer to really emphasize how important this is. You must have the name of the dictionary you want to use. You know, you can pick whatever name you want. This is just like a variable. Followed by the equal sign, followed by the brace, the curly boy, and then enter. Now, technically, you can have it all in a single line if you want, but it's not as clear later on. However, you must always have the curly boy on the same line as the variable name and the equal symbol. That cannot change. If this curly boy was on the next line, then this code would not work. It has to be on the same line that the equal sign is located in. Now, then you just start writing the entries you want in the dictionary. So you write whatever you want your first key to be and whatever you want its associated value to be. You separate them using a colon, and then at the end you put a comma if you want to do more entries. If you don't want to do any more entries, you just, you know, put nothing at the end. It's kind of like a list in that way, where you just separate by commas the entries. Now, you can put as many entries as you want. You know, here I have 3. You know, I have key 1 with value 1, key 2 paired to value 2, and key 3 paired to value 3. But you could have 100, 1,000, as many as you want, or as little as you want. You can make an empty dictionary if you want down here. There are ways to add and remove entries from a dictionary, which we'll get into later on. Alright, so how would we create the above dictionary that's on the screen in Python? Like, what exactly would we have to type to do that? So this is how we would create a dictionary in Python, that exact dictionary. But let's actually look at it in code. Okay, so I copy pasted the code segment onto my Visual Studio Code. This is what I'm going to be using for this video. So I'm going to be using Visual Studio Code to write all the code and my terminal to run it. Now, if I were to make this dictionary just like this, and then if I were to print it, it would print it kind of like how a list is printed when you try to do it like this. So if I were to run it, lecture.py, it prints it out, but it prints it out in a not very easy to understand way. So if we read through the whole thing, we can see that car is paired with automobile, comma, which means that's one entry. Then cat is paired with domesticated carnivore, comma, that means that's that entry. And then catapult is paired with an ancient blah blah blah, comma, so that entry is done, and so on and so forth. So the colon tells you it tells you the thing to the left is the key, the thing to the right is the value. It just shows you that pairing. We could have added more or less. Like we could have done, let's say, calculator, and then a calculator is a machine that does cool calculations. Then that means you have to have a comma up here. Now if we were to run this again, now we have calculator, you know, in the list, in the dictionary. I could have also removed a couple of these. I could have removed catapult and microcontroller, and then ran it, and now they're just not in there. So you can have as many as you want or as little as you want. We could have even gone with nothing in it, and it would have worked. You see? But it would not have worked if the brace was on the next line. So check this out. See, it just immediately crashes because when Python is running, it looks at this, and then there needs to be something next to it. Like it's expecting something. So that's why this curly boy has to be on the same line in order for it to work. We could have also, like I said earlier, had everything on a single line. So we could have had like cat, cute animal, and then we have, dog, another cute animal, and then we could have, let's say, bird, a cute flying animal with feathers. And this should work. Oh, sorry about that. See, so this works as well. So they don't have to be, spread up like this, but it makes it a lot easier to read and understand what's going on. Let me fix that indentation real quick. If you run it again, it'll still work. But again, make sure the curly boy is next to the equal sign, not in the next line. Alright, so now we kind of figured out how to make a dictionary, but that's kind of useless. So, what does this help us if we know how to make a dictionary, if we don't know how to use it, how to traverse through it, how to look up stuff in the dictionary? So on screen, it's the two ways you can do that in Python. You could do it using like the index method is what I like to call it, because it's just very similar to a list where you have the square brackets and then the index inside, or the get function with the index. Now, throughout this video, you'll hear me using index and key. They mean the same thing for dictionaries. An index and key are just what you look for in the dictionary. That will give you the associated value. So this is examples of how to use that. Now let's look at our code again to see how we would use these two methods to actually look up stuff in the dictionary. Alright, so this is the same code I had before. But like I said earlier, what if you want to access a specific entry? What if I just want to know what cat, means? So, or what cat is paired to? Now, if we enter cat and we print it, oh, let's see what happens. Oh, see, I didn't fix the code earlier. Remember, the braces have to be on the same, the first brace has to be on the same line. Now let's run it. So if I do this, I get a cute animal. But if I were to do dot get cat, yep, that should be everything. Oh, comma. It's supposed to be a period. Alright, so see, we still get cute animal. Now let me clear that and run it again. So, cute animal, and if we were to change it to the braces, to square brackets, we also get cute animal. These are completely equivalent ways of doing this. You could do either one, and it would still work just the same. Alright, so far we've been looking at dictionaries that are pretty much identical to real-life dictionaries, right? You have your word and you have your definition. But that's not all a dictionary can be. Like I said, in Python, a dictionary is just a key and a value. They don't have to be strings. They don't have to be, of the same data type. You can have a, a mismatch of, data types across the keys, across the values, and, across both at the same time if you want. Like, these are two completely valid dictionaries. We'll look at them a bit closely in the code in a second, but I just want you to look at them. Let me get my fancy laser pointer. Now, this is a weird int dictionary. You know it's weird because I named it my weird int dictionary. And the keys are just numbers, 0, 1, 2, 3, 4, 5, and then the values are all sorts of different data types. The first one's just a boolean, the second one's a float, third one's a string, the fourth one is a list, the fifth one's a float, and then the last one's a tuple. Like, there was no consistency here at all. And then on the other side, we have a string for our first key, then two floats for the next two keys, and a string again, and then an index, and then all of these are completely different as well. These are all completely valid dictionaries. You have to remember the dictionary is a collection of entries, and each entry has two parts, a key and a value. Nowhere in that definition does it say that all keys have to be of the same data type, all values have to be of the same data types, keys and values have to have some sort of matching data types. It says that nowhere, so don't put that limitation in your head. You can do whatever you want with dictionaries as long as you follow the general rule of key and value. Alright, so I have the strange dictionaries copied over into Visual Studio Code, and if I were to try to print them out, let me clear the console. Alright, let me copy paste these lines. they'll print out just fine. I can even use the index method to, see what's in them. So let's say I want to see what is at 4. And over here, I want to see what's in 3. And we run it. At 4, there is a 4.00, and at 3, there is a list that has 1, 2, 3. Now let's change this again. Let's say I want to see what's in 0 in the weird int dictionary, and I want to see what is in 2.00 in the very strange dictionary. So false is in both. Let me change the very strange dictionary to 3 now. And let me change the weird int to 5. And in the very strange dictionary at 3.00, there is a list. And in the my weird int dictionary at 5, there is a tuple of 1 and 2. So as you can see, the keys and the values have no data type requirement. I use strings, I use ints, I use floats. I could even use booleans if I wanted to as keys in this. There's no restriction. You could use whatever you want as a key as long as it's already in the dictionary. If I were to try to look for something that's not in the dictionary, like 1 is not in the dictionary, the literal integer 1. And if I were to look for false, uppercase false, which is not in a dictionary, if I were to do that, let me save my code, I get an error. We'll go into that a bit later, but I wanted to show this to you guys now in case you had this question. Now, if I were to add, a 1 to the list, let's say 1 is I added this for the example, and we run it again. Now, it will work because 1 is already in there, and so here's something that I didn't realize what happens. So false is really the same as a 0. So this second line is working because this 0 is there. If I take it out, it shouldn't work. Let me see if that's right. So see, it doesn't work. It needs to be in there. And another fun fact, I think true actually is a 1 in Python, and that means we should see a 1 being printed. Let's see. So see, that's true. So if we had like a 5 would print out instead. So that's a couple of things you have to keep in mind when you're using a bunch of different data types. You have to think about how they would interact with each other. Okay, so now what if we want to add to our dictionary? What if we have a dictionary that lists the qualities of a house, and now the house is a garage, so we have to add, data about that. So it's very easy. All you have to do is just, use the index method of accessing an entry in the dictionary and just write it. So if the entry does not exist, it will just create it. So this is how it looks mechanically. We have the dictionary we want to add a new entry to, the new key we want to add, and the new value we want paired with that new key. So this will add another entry to the dictionary. Let's look at that in code real quick. Alright, so I made a really quick dictionary called My Cool House, which has a bunch of attributes of a house. This house has 2 floors, it has a garage and a pool, 3 bedrooms, and 2.5 bathrooms. So I added each of those attributes to the dictionary as its own entry. So I have the 2 floors, that's one entry, the garage has its own entry, and so on and so forth. So if I were to print out, sorry about that. If I were to print out the dictionary, we get all of the attributes, printed. We have the 2 floors, the garage, pool, and so on and so forth. Now, since I'm such a handy guy, while we were talking, I added a balcony to the Cool House, but I added it after the Cool House dictionary was made, so we have to, add it to the dictionary. And the way we do that is just how we, discussed last slide. We just do My Cool House, and then we do, let's say, balcony, and then equal, let's say, true. So I'm adding the new key here in the square brackets, and then I'm adding the value that's going to be associated with that new key there. And if I were to print it out again, we see that the print statement before the addition does not include the balcony, and the one after does include the balcony. And I can add as many things as I want. Maybe my house has a no pets policy, right? So let's do pets, and then let's say that's false. And if I were to run it again, now we have two additional ones. I guess an important thing to add to your house would be the value, right? And since my house is so cool, the value is at a whopping, 10 million and 99 cents to make it look a bit cheaper. And if we were to run that, then that's in there as well. Now, we can add as many as we want, and this will work just fine. There'll just be additional entries on the dictionary. So we learned how to add to a dictionary, but what if we want to modify a previous value? We did say that dictionaries were changeable, so let's find out how you actually change a dictionary. So the general process is using the key. Everything in a dictionary requires that you have a key. So using the same format you use to add a new entry, use that, but instead of using a new key, use an old key that's in the dictionary already, and that will update its value. So now I want you guys to think for a moment real quick. So let's say I have that dictionary down there, and I wanted to modify, all the fields, to reflect a new car purchase. How do you think this would work? How do you think this will look like? We'll do this in a couple seconds, but I just want you guys to start thinking about what that might look like in the code based on what I've told you and what dictionaries actually look like. Alright, so I have the dictionary over in Visual Studio, and if I were to run this program, it'll print the dictionary twice. So I have it twice so that we can modify it in here, and then we can see the difference easily. So now, let's say I bought a new car, congratulations. I'm going to pat myself on the back for that one. And we have to change the brand, so we have to do the little indexing thing using the key we want to look up. And now we're accessing the brand key, which corresponds to this entry. Now, if I do equals and then update it so, the brand used to be a Toyota, now it's a Tesla. Yes, again, patting myself on the back. And then let's say the model I got is a Model 3. So we have to do model, and then we do Model 3. And the year is a 2021. So let's do 2021. The safety, gotta do the thing first, right? So safety is going to be a true. And then the value will go up immensely from negative $1,200 up to a ridiculous $50,000, I think those cars cost. So let's just put 50,000, and if I were to print it, everything's updated, right? So now the brand is a Tesla, the model is a Model 3, years 2021, and so on and so forth. So this is how you were to update the entries in a pre-existing dictionary. All right, but what if we add an entry we later want to remove, right? Because we've talked a lot about modifying existing entries, adding new ones, but we haven't really talked about how you get rid of one you don't want. So there's two specific ways you can remove entries in a dictionary. Using the del, delete keyword is one of them, and then using the pop function is another one. Now, they both do the same thing, but they have slight differences. So using the del keyword, you remove whatever entry is in the list if it exists. So you just do del, the dictionary name, and then the key of the entry you want to delete. But if that key doesn't match to any entry, if that key doesn't exist in the dictionary, your program will raise an exception, which is code for it will crash. So it's not very safe, and I do not recommend it. Now, there's also the pop function. Now, pop is a very special function because you will hear it a lot in programming. Pop is a function that is present in a bunch of data structures, and they generally do the same thing. Pop just means delete, kind of. So you can use pop in one of two ways. You can use it using the single parameter way, which is just works the same way as delete. You just do the dictionary dot pop, and then the key you wanna, of the entry you wanna delete, and then it'll delete it if it exists. If it doesn't exist, it will also crash. Now, it will also do something pretty cool. It will return the value that was popped. So if we do a key that exists, and let's say we do key A, and at A the value 42 was located, it will return 42. So you could, see what you deleted based on the value, not just the key, which is pretty interesting. Now, the more useful pop function to use is the two-parameter one, because it works the same way. The first parameter is the key of the entry you want to delete, and then the second parameter is the value to return if the entry doesn't exist. So if the entry does exist, the second parameter isn't used at all. But if it doesn't exist, then instead of crashing, the function will just return that value. So it's very useful to set that second parameter to a value that cannot be found in the dictionary. That way you can check if your pop was successful or not. Alright, so I brought back the original dictionary we were messing around with, and I have the two functions commented here. I have them commented here because I usually mess something up when I'm writing them, so that way I can just copy paste them. So if I were to run this program, it'll print out the words and the definitions we have. But let's say we want to delete the entry at cat. Let's say we don't want cat to be in our dictionary anymore. So we do dull on my brand new dictionary at cat, and then we print it out again. So if we see cat was in there originally in the print statement before the delete, and then it's not in there afterwards. And then we can delete all of the ones in here if we want, or we could just delete one of them. But if we try to delete something that's not there, let's say 6, there is no key that's 6 in here. So if we were to do that, we're gonna get an error. You see, it says key error. That's just code for saying, hey, this key doesn't exist, I couldn't find it. But that's not just because it's a different type, because like I said before, dictionaries don't care about types. If we were to do calculator, which is not in this dictionary that we have here, we'll get the same thing. Now, there are ways around this, which we'll cover soon, but what I would prefer you guys to use is to use the pop function. Now, the pop function will work very similarly to the delete function, but to the delete keyword. But instead of just deleting, it also returns what it deleted. So if I do, let's say, value deleted gets that, and then we were to print that out, print the value deleted was, and then we do str value deleted. I run that. Let's see if that works. Yep, that worked. Okay, so if we look through it, we first printed it out, then we deleted it using a pop. But when we did our pop, since cat was in there, it returns domesticated carnivore, which gets assigned to value deleted. Then we printed out value deleted, which was domesticated carnivore, and then when we print out our dictionary again, it's not there. This is very useful because you can use it again to see what you deleted. And when you're doing more advanced programs, you might have dictionaries filled with numbers or values that actually have some logic tied to them, which you can use to do some pretty cool stuff. Now, let's say we tried to pop something that was in there. Let's say we try to pop calculator, which again is not calculator, which is not in there. If we're to do that, we get the same thing, another error. But if you use the two parameter version, um, and then have another value here, let's say I did not find, or instead of that, the key was not in the dictionary. Let's do that. If we were to do that, it works. So nothing's deleted, but what ends up happening is that it tries to delete it, it doesn't find it, it doesn't crash, which it would normally happen if we only use the one parameter or the del keyword, and since it's a pop, it has to return something. So what it returns is this. This is only returned if the key is not found in the dictionary. So since it's returned, value deleted gets it, and we can see on the next line that the key was not in the dictionary. Now, if we were to have delete catapult, I don't know what you want to, delete catapult, because catapults are pretty cool. But say you did, you're not in your right mind, and you want to delete catapult. If we run the program now, we'll notice that the value deleted variable gets the definition of the catapult entry, what the value that key is tied to, and not this. This is only used if the key isn't found. Otherwise, it behaves identically to the pop function with a single parameter. I highly, highly, highly suggest you use this method of deleting values. And you could use whatever you want. We could have used like a -1 if we wanted to signify that the key wasn't in there. So if we do like let's say truck, truck's not in there, the value deleted was -1, and -1 would be stored here as an integer, which we could do some really cool calculations with. We could do a very simple comparison saying we could do something like if value deleted equals -1, then we do print the value, the key was not found, else we actually do all this stuff. So see, now we added some cool logic. Now we don't have that weird thing where we said the value deleted was not found. So like now we have some pretty cool logic in here. So now if we do car, which is in there, we get the value deleted was automobile. So that is a very cool way you can use pop to implement deletion and add some really cool logic so that your program is pretty nice and easy to use. But what if you want to delete the last entry in the dictionary? What if you don't know what the key is, that you don't care to find out? You just want to know, you just want to delete the last thing placed in the dictionary. Well, there's a function for that. It's called pop item. And all it's going to do, it's going to delete the last thing that was placed in the dictionary. It will also return the value of that entry, just like pop does. So let's see that in action real quick. So if we look at the code here, I went back, on our code a bit and removed all the stuff we added. The last thing added to the dictionary is microcontroller. So if we do my brand new dictionary.pop item, just like that, we expect microcontroller to not be in the dictionary. So let's run it and see if that works. And it did work. And if we were to do value deleted gets that, and then we do print the value deleted was, and now we do str value deleted, now we run it, it'll work just the same. But however, it returns the entire entry as a tuple. It doesn't just return the value, which is pretty interesting. I could have sworn it returned just the value, but it apparently returns a tuple, which is pretty cool. But in essence, it's still the same thing. It gives you back the thing that was deleted. Now, you can use this as many times as you want. Like I could have done, let me remove all this. Now I could have done this twice you know, in a row, and then catapult would have also been deleted, you know, as if I'm a madman, you know. And now we're just left with car and cat. And then I could add a couple of more to this dictionary. I could add, you know, I could add, let's see, 5, which corresponds to blue. I could add my brand new dictionary. I could add 3.1, which corresponds to false. And if we print it again, there's going to be 2 new entries in there. You see? And if I were to do pop, which do you guys think will get deleted? You know, I'll let you think about it while I copy over this. All right, so let's see what got deleted. So 3.1 got deleted, and you could keep popping as much as you want. You know, there's no rule that you can't pop, you know, too much. You know, unless the list is empty. You can't pop once you popped everything, you know. So if we go back to that, yeah, so now our list is empty. So if we were to try to print it, we're just going to get empty list. So that's one way you can delete the last thing added, which is useful sometimes, but that's just another deletion method that's really specific in its use case. Instead of deleting anything you want, it only deletes the latest thing you added. Alright, so I want to make sure you guys are paying attention. So we did do this a couple of times before. So what do you think is going to happen if you try to access a key in the dictionary that isn't there? What do you think is going to happen if you try to find an entry in the dictionary that doesn't exist? So these are our 4 options. You know, nothing will happen, a null value is returned, a 0 is returned, or the program crashes. I've done this a couple times, but I want to make sure you guys are paying attention. So, you know, think about this real quick, and let's just check. All right, so let's check real quick. Let's say entry 3. Let's see what happens if we try to access that. And immediate crash. Now, this is problematic because what if we want to check, you know, what if I have my house dictionary and I want to check if they have a pool, but they never considered adding that entry to their dictionary? Checking could lead to a crash, so, you know, we have to figure out a way around this. So let's talk about that real quick. So to avoid this, all we have to do is use something called the N keyword. This will allow us to check if a key is present somewhere in the dictionary. So this is how you would use it. You do if the key you want to check is in the dictionary you want to check, and then that if code block is going to run only if that key is present. If it is not present, it won't run. So this is a very good way to safely check if a specific entry or a specific key is present in the dictionary. You should always be doing this because directly checking, looking up a key in a dictionary is a very risky endeavor, because if it's not there, then the program crashes. You know, that's just how it goes. But if you check before, you can prevent this. You can only make it so that the actual accessing operation only occurs if it's actually there. So let's look at that in code real quick. So going back to the earlier code we had, this is how we would check. So let's say we want to check if 3 in my brand new dictionary. And then if we do that, then if it is in there, then the key is in the dictionary. Otherwise, it is not. So let's see if that works. The key is not in the dictionary. So let's see if that works. So it's not. So if we try to do car, the key is in the dictionary. And then you could generalize this out. You could do key gets 3. And then if key, the key is in the dictionary, so we could do the key, and then we could do something like this where we do plus str key close. Oh, close it, and then plus again, and then remove one of those. Dictionary, and then we can access it. So then we could do something like my brand new dictionary key, and then we print it out. So let's look at that. Oh, it's not in dictionary, and then we could do cat because we know cat is in the dictionary. Yeah, so it is in the dictionary. And oh, let me add it to the other one so it's nicer. So if we do that, let's run it again, and then we had 5, 6, sir. Yeah, so this is how you could generalize your dictionary accessing to make sure it's safe. Obviously, if you were using this to make sure it's safe, you would remove these print statements, or keep them for debugging purposes, but make sure if you're doing an assignment where you need to access some dictionaries, or if you're, doing some sort of, if you're working and working with with dictionaries, you're going to want to remove these print statements, or at least have them commented out, so that if you need to do some debugging, you can quickly use them. So sometimes it might be useful to find out how many entries there are in a dictionary. And an easy way to do that is just doing the len function, which just returns how many entries there are in the dictionary. So let me show you how it's used real quick. Alright, so this is how you use it. You just do len and then the name of the dictionary you want to use. Now this will return an int, so if you run it, nothing's going to happen. But if we were to print it, let's do a quick print statement. And then we do our len, and now we need another paren back there, and then rerun it. Now we get 4 because there are 4 entries in there. And let's say we were to delete, well, not delete because delete's risky. Let's do pop my brand new dot pop. Oh, not poop, pop. Microcontroller, and if it's not in there, return -1. It's in there, so we're good. And then we print out the length. So let's see. Oh, let's see what happened. It isn't in there because I typed it wrong. I typed microcontroller, not microcontroller. So let's fix that real quick. So see, now it went from 4 to 3. And then if we were to add something else, so let's say we add so the pizza key, let's say we add the pizza key, and we say something like it is technically a sandwich with only 1 slice of bread. So we say something like that, and then we check again, see a 1 up. So this could be very useful. We could have a check that says that differentiates between large dictionaries and small dictionaries. So we could have something like, if len of my brand new dictionary is greater than 5, then we do some stuff like, whoa, that's a big dictionary. But if it is not, then welcome to Weenie Hut Dictionary. You could, home of the Tiny Dictionary Club. So this is something we could do, because maybe we want to use one algorithm if there are a lot of entries in the dictionary and runtime matters, but maybe we want to use a different algorithm if there aren't that many entries in the dictionary, and using a easier but less efficient algorithm doesn't make that much of a difference in the long run. So let's try this. Alright, let's see what happened here. My brand new, so I messed up here. Let me fix that real quick. So the parens, you gotta be careful with your parens, and it's okay to mess them up the first time, but you have to understand what the error is saying before you can fix it. So I usually, whenever I'm making any coding mistakes on these videos, I like to keep them in so you can see that everyone makes mistakes while coding. It's completely normal part of coding. So let's run this and see what happens. Okay, so let's see how many we had before we got it in there. And when we run it, we have 5. which is, you know, not greater than 5, so we have to go into Weenie Hut Dictionary. And if we were to add another one, let's say jam, and then we could call it, we could say that jam pairs with, it is thick juice or something like that. You know, something non-controversial like that. And then we run it, and now we have 6 entries, so we are a big dictionary now. So that's some way you could use the length of a dictionary to your advantage to do certain things based on the size. Alright, so sometimes you might get a bloated dictionary, you might have filled it up with too many things, and you need to empty it out. And the way you do that is just by using the clear function. Alright, so let's check that out. Alright, so here we have the old code we just had with the my brand new dictionary with all those weird entries. So let's remove that extra stuff that doesn't matter, and let's run it again. Oh, let's see what happened. Unexpected line. Let's run it again. Let's see what's going on. Oh, see, we had a unmatched paren there. So let's run it now. Alright, so now it's working. So we have a couple of entries. We have 6 entries. We have, you know, car, automobile, cat, domesticated carnival, catapult, an ancient military engine, blah, blah, blah. Microcontroller, a small general purpose computer. Pizza, it is technically a sandwich with only 1 slice of bread. And then jam, it is thick juice. Now, some may call this dictionary an abomination. I would disagree. But if you know, want to, you know, clear this all out because it's getting a bit crowded, you know, a bunch of categories here are mixing. We have, you know, pizza stuff like, not pizza stuff, food stuff like pizza and jam. And then we have, you know, car, cat, catapult. You know, maybe we want to sort our dictionaries out into different, you know, categories. So what we just use the clear function, right? So we would do my brand new dictionary dot clear, and then let's try to print out that dictionary again. And if that happens, we get an empty dictionary. And this also resets the len, you know, the length of it. So let's do that real quick so you guys can see it. It'll reset it down to 0. So see, it went from 6 somewhat unrelated things down to 0. So this is a way you could clear out your dictionary while the code is running. Maybe you want the user to be able to modify the dictionary and also give them the option of resetting it entirely. You would do that using the .clear function. So a really cool thing we could do is we could actually iterate through a dictionary. Now, in the last lecture, we talked about iterating through a list. But the thing about iterators is that they work on a bunch of different things. We could use an iterator on a dictionary as well to iterate through everything. Now, the general structure of it is down on the bottom of the screen, and the way it works is that it iterates through the keys in the dictionary. So as each iteration goes, X becomes each key in the dictionary. It's easier once you see it in action, but let's check it out real quick. Alright, so I have the original dictionary we started with here, and a thing we could use the iterator for is printing this out in a nice way, because right now when we do you know, print my brand new dictionary, you know, it's a bit ugly the way it's being printed. So what we could do for current key in my brand new dictionary, we could do that. And then we could do print, we could do str current key plus, and then that maps to, let's say my brand new dictionary current key, and then yeah, this would work, right? Yeah, this would work. Now let's run it. Let's see what happens. So yeah, it worked. And you see how we're printing it in a much nicer way? Now, if we take a closer look at this, what's happening is that each iteration of this iterator goes through every key in the dictionary. So first, it's the car key. So we do car, and on the first iteration, current key is equal to car. So it prints out car here, it uses the car here as the key, and it returns automobile. And then the next iteration, key is now cat. So it prints out cat here, and then it looks for the entry associated with cat, and so on and so forth. Now you could use this to make some really fancy prints using dictionaries, and you can make a bunch more logic. Like you could you know, if you have a dictionaries full of numbers as the keys, you could figure out how many of the associated values are encountered. Like you can make like a histogram. Maybe we have a dictionary that lists, you know, animals, and then the associated value with that animal key is how many people like that animal. And then you can make like a histogram. You can keep count of everything as you iterate through it. So iterators are extremely useful, especially with dictionaries and with lists as well. But this is a very handy tool that you can apply to dictionaries to make some really cool code. So I've said this a couple times during this lecture, but you know, dictionaries, they can hold any kind of data type. You can even put list in there, and that has a pretty useful and neat functionality because paired with iterators, you can make some pretty cool programs using dictionaries that contain list. So let's see if we can write a quick program that does that. Okay, so I started us off with a blank program. Let me clear the console real quick, and let's make a dictionary called my favorite things. And then we're gonna have a string as the key, so we could say colors, and then we have a list associated with that key, and then I'm just gonna list my favorite colors. Pink, the manliest of colors, blue, and gray, sure. Um, and then we could have numbers, my favorite numbers. I like the number 1. 2's pretty neat. Pi is a good number. What other number's pretty cool? I like the number 47. That's a pretty neat number. Um, and that's about it in terms of numbers. Now, my favorite video games, let's just list a couple there. I like, you know, Fall Guys is pretty cool. I'm playing that a lot right now. Pokemon Platinum is the superior Pokemon game in my opinion. And I really like Half-Life 2. That probably dates me by quite a bit, but yeah, I really like that game, so let's include it on there. What other stuff do I like? I like movies, so let me see. You know, Inception's a good movie, so let's include that in there. And I also like Iron Man 1, very good movie. Let's put one in there. And another cool movie, let me think. You know what? I'm good enough for those. If I want to add any more, we could add it. And then if we were to print this, it's not gonna print very nicely. So let's try to print that. So if we were to try to print it, it's oh, let's see what happens. Oh, see, I use equals. No. It's colons. See, that was on purpose. I want to see if you guys caught me. So it's colons, not equals. So now let's print that, and now it works. But this is a mess. Like, what the heck is this? How do you know what's where? Now, a cool thing you could do the iterators. Now, if we do for current key, this doesn't have to be named current key. I could name it X if I wanted to. My favorite things, and then we do let's say we print out let's say we just do the same thing we did earlier and just do and then we do, let's see, and then plus, and then we do my favorite things X. Yeah, that'll work. So let's see that. Oh, sorry about that. Let me run it now. Oh, let's see what happened here. Oh, see, I forgot to do str because not all of these are strings. Is it gonna behave now? Yeah, so it's behaving now. So now I'm listing everything out, like, you know, in a line in a much easier to follow way, but it's still not as nice as it could be. And we could add additional logic to this because we could do something like, for example, x, the value at this paired, you know, this value is gonna be on a list, so we could do some cool stuff with that. We could iterate through the list itself as well. So let's try doing something like that. Let's see what happens if we were to do something like that. Um, let's say we print out what it is, and then we do another iteration for y in my favorite thing x. Let's see what would happen. I'm not too sure what would happen, but you know, we'll go through this together. Let's see what happens. Oh, that's pretty cool. So what it does is that it's going to print out every individual thing, because, you know, y is now the list. So, I mean, the entry in this list. So we could, you know, do a bunch of cool stuff there. So this is just a hint of what you could do in your program. So we could have done something like this to make it a bit easier to look at. So now the categories are kind of, you know, split. We could have done something like, let's add just a couple of spaces in there, or just like something like that. That's pretty cool. And then yeah, so see, everything's in their own category. That means we could just remove this. Let's just remove that. Yep, and let's run that. And as you can see, you know, you could do some pretty neat stuff using iterators on dictionaries and the list within. And like I said, you know, since each value paired with the keys are list, then I could do some interesting stuff with this. I could do my list and then print out the length of it. Like I could do length of this list, you know, if I wanted to print it so that I know how many more I'm expecting. Like I could do something like plus, you know, there are len. So, yep, there we go. Oh, I didn't need all that. We do need str though. And then we do entries in this category, something like that. Let's see if this works. I'll be very impressed if it works. All right, let's see what happened. Oh, see, I forgot the other paren here. Does it work now? Let's see. Unmatch paren. Oh, yep, there is one right here. 6. So let me see. X str. Oh, so see, we have to let's see. X. Oh, we have to do my favorite things. See, because we want the list, not the actual key. We want the value. So let's check that out now. So yeah, see, now we could do some cool stuff. So, you know, we could just do cool list stuff to each one of the lists found in here. So this is just a quick sample of what you can do when you mix dictionaries and lists together. It's just, I thought it was pretty neat, and it might be useful in one of your assignments. You know, hint, hint again. Alright, so what if I want to copy a dictionary? What if I want to back it up somewhere? Well, the thing about dictionaries is that they're technically objects, not primitives. Lists are objects, dictionaries are as well, like I just said, but that means you can't just assign, you know, a new variable, you know, a dictionary and expect it to be a copy of it. Because what's going to end up happening is that you are just going to make the new variable a reference. So on the screen on the top, you see I have new dictionary gets old dictionary. That's not going to make the values of old dictionary be copied into new dictionary. Instead, it's going to make old dictionary give a reference to itself to new dictionary. And then what that means is that anytime old dictionary is changed, new dictionary will be changed as well. The way you actually copy a dictionary is using the .copy function shown at the bottom of the screen. All right, so let's try that out. Okay, so we're back here with all reliable, and I have the 4 entries. Now, if I were to do my copy of a new dictionary, you know, gets brand new dictionary, then it's not going to behave the way we expected. So let's try printing them first to see what happens. And then we do print again. Oh, let's see what happens. So at first glance, it looked like it worked. You must be like, Jan, you're crazy, it's working. But if we were to modify the, let's say we want to delete, let's say, microcontroller from, my brand new dictionary, since it's a copy, right, you expect it to, be deleted from my brand new dictionary, but not from my copy of a brand new dictionary. So let's check it out. But as you can see, it was deleted from both. Because like I said earlier, since these are objects, you can't just copy them directly. And we'll get into what objects really are in a few lectures. But for now, just remember that dictionaries you cannot copy like this, and you can't do it to lists either. So to actually copy them properly, you have to do the .copy option. And I believe this works both ways. I'm not sure. Let's check. If we were to delete catapults from the copy, the quote-unquote copy that we just did, I believe it will delete it from both sides. But let's check. Yeah, so see, it deleted them for both sides. So it's a two-way street. So we have not created a copy. We just kind of, made two variables that point to the same thing, which is actually what's really happening in the compiler, in the interpreter, I mean. Now, if we were to actually want to create a copy, then we have to do .copy. And if we run it now it works. See, now the first time we print it, they're identical. And then I delete microcontroller from my brand new dictionary and catapult from my copy of a new dictionary. And we can see that microcontroller is not in my brand new dictionary, and then my copy of a new dictionary does not have catapult. So that's how you actually create copies. You have to do the .copy. It's very important. Alright, so the main takeaways from this lecture is that Python dictionaries are very, very similar to real dictionaries. They work the same way. In a dictionary, you have a word that you use to look up a definition, and in Python, you have a key that you use to look up a value. They are functionally the same thing. They behave very similar to lists, but with some very noteworthy differences, and they are very powerful. They really let you make some cool logic in programs. They are very, very, very useful to use in conjunction with lists. Making dictionaries with lists within them is a very useful thing. Some programs might benefit from that greatly. And the other way around also applies. You can make lists with dictionaries within them, and that's also very useful. You could also make dictionaries with dictionaries within them as well. You could put whatever you want in a dictionary. And the thing about dictionaries, they're very easy to understand, but they're very hard to master. So what I suggest you do is to rewatch this video if you have any lingering doubts. And after rewatching it, if you still have any doubts, try to look it up. Just Google, a little bit about dictionaries. Try some stuff out yourself, and email us if you have any questions. We are eager to answer any possible questions you may have. All right. All right, so have a good day. I hope you guys, enjoyed learning about dictionaries.